Okay guys, here is something called Conic Sections, and I'm going to do an intro to this concept, and I apologize in advance for the fact that it is extremely difficult for me to draw a perfect circle. So, we're going to start here with circles. Well, a circle is called a conic section. What do I mean by that? Well, I have a picture of the 4 conic sections. So if you have cones, right, and then you take a 2-dimensional plane, like here in the picture, there's a 2-dimensional plane, and you slice it through the cone so that it is parallel to the base of the cone, right, parallel to it, what will happen is the shape you generate will be a perfect circle. Now, if you take that 2-dimensional plane and you tilt it slightly and still slice it through a cone, you'll get an oval shape. An oval shape is called an ellipse. If I were to slice one of the cones so that the 2-dimensional plane was parallel to the outside of the cones, you generate a parabolic shape, or a parabola. I'm going to tell you right now, there are no conically defined parabolas on the AP Calc Summer packet. So I'm going to save you some time here, and I'm not going to even go through those. And then the last one is, what if you took that plane and you stood it up and cut it through these 2 cones so that it was perpendicular to that base of that cone? Well, it would hit both cones and it would draw out what looks like a double-sided parabola. This guy, and then this one up here. So it looks like a parabola going up and a parabola going down. Well, that's a hyperbola. So on your AP Calc Summer packet, you're going to run into the circle, the ellipse, and the hyperbola. So I'm going to focus on those. Now, I wanted to kind of remind you guys, though, that the equation for a circle, like a very basic circle with a center at the origin, is right here. X squared plus y squared equals r squared. So let's just start with circles, since I know you've seen them in geometry class, and we'll just sketch a couple, and this is where I'm going to totally apologize for how bad my graphs look. So here we go. I'm going to sketch a couple circles here. So let's say they gave me something like x squared plus y squared equals 25. Well, that would mean that's the r squared part of the formula. So my radius would be 5 units. Now, I know that when we solve for r, we root, we'd get plus or minus. But since a radius is something you would measure out 5 units, we disregard the negative. We don't count that. Whoops. We just count the 5. Because a radius is a positive length. So here we go. I'm going to draw a coordinate system. And then I'm going to say center is at the origin. And if I went out 5 units, that would be my radius. And if I were to rotate that around, here we go. Wish me luck. I could, oh my God, that wasn't the worst circle I've ever drawn. But really, it's hard to draw a circle freehand. It really is. Meaning, that would be my circle. That would be the equation that represents that. Now, I know you've seen this in geometry. But the reason this is centered at the origin is we didn't write it out formally. X minus h squared plus y minus k squared equals r squared. Now, this is the equation of a circle if you're going to affect where the center of that circle is located. Now, I'm mentioning this because, look right here, this is what I'm trying to get at. In this question here on the AP Calc Summer Packet, question 12, we have a circle. Now, we do have an inequality for that circle, but that's okay. We can do that easy. But what I'm trying to get at is, how do we sketch a circle when it's not just a simple equation like this one? It's not too bad. Let's take a look. So here we go. If I wanted to sketch a circle, and let's say they gave me more information now. Let's suppose they gave me this. And I'm going to make it easy on myself. I'm going to make a smaller number there. And then this would be a circle, but the center would be at -1, 3. We've done this before. When we are shifting graphs, anytime you see something written in parentheses, what you're doing is you're setting it equal to 0 in your head. So the sideways motion, the lateral motion would be, well, -1, so 1 unit to the left. And the up or down motion, that's the y motion, well, it would be right or left, you know, whatever it is. So this would be right 3. And if I go right 3, put those two together, there's my center. So let's try and sketch this one. Here we go. Going to draw it out. I don't know if you guys can hear the cars whizzing by me, but I am making this video in a busy area. Anyway, 1 to the left, 1, 2, 3 units up, there is the center of my circle. Now, just like we did with the last one, r squared would be equal to this 4. I would take the square root of both sides. That was kind of bad. R equals, now it's a positive thing because it's a radius, so we don't say plus or minus 2, we just say 2 units. So here we go. I could mark over 1 unit, 2 units, right? And then that would be my radius of 2. And wish me luck, I would sketch out a circle. Oh, God, that's horrible. With a radius of 2. Now, I think you guys could handle this one that is included on the AP Calc Summer Packet. I think you could totally do this. But what about the inequality? Well, let's go back. Let's pretend this said less than or equal to 4. Well, what does that mean? It means when I sketch my circle, I'm going to have a solid circle. And less than that would be all the information. Here, let me get a different color. All the information inside the circle. Less than 4. Okay. Hey, let's play the game again. What if the original problem said, and I'm going to erase this, and I'm going to put it the other direction. What if the original said greater than or equal to 4? Well, I would still have a solid outline of this shape, I would, but instead of being the information internal, it would be the information now that is external. So it would be all of the information outside of that circle. Now, I could keep coloring forever and ever and ever, but I think you guys get the point. That would be that. So how do I handle a situation when there's not the potential to be equal to? Well, let's just, you know what? Let's do a separate example. We'll get one more example in here, and we'll play it from there. So what if they gave me something like this? What if they said x squared plus y minus 2 squared equals 9. And I'm not going to use an equals, but I want you to see that would be a circle. And you might say, but wait a minute, what about this? There's only an x squared here this time. Well, if it makes your brain happier, I'm going to erase this. I could do this. I could have written it like x minus nothing squared. And then it has that format that we're used to. What format we're used to? This guy right here. This format, or we don't say format in math. What do we say? We say formula. So we have that, and that means I am going to go no motion sideways to find my center. However, for this one, I would go up 2 units when I sketch this graph. So here we go, and away we go. And I'm going to go up 2, and I'm going to put a dot. And I bet you guys have already figured out my radius. You are probably not saying, I'm going to write this little equation out and do this and say r equals plus or minus 3, but it's a circle, so I only use the positive part of the 3. I don't think you're doing that, but I do want you to know it all comes together and, to make this picture. Now, if it's equal, you draw a circle. If it's less than or equal, you would draw a solid circle, but you'd color the inside of the circle. And what if it said greater than or equal? You'd draw a solid circle, and then you would color the outside of it. So what do you do since this one, let's say, looked like this? What if it didn't have the potential to be equal to? What if it didn't have that little symbol? Well, here's how we handle that. We would still say I have a radius of 3 units. So I'm going to go 1, 2, 3 units, right? And then I would sketch my circle. But instead of a solid, solid line to create this circle, I would have to draw it using a dashed line. So that's the difference between less than or equal to, less than, greater than or equal to, greater than. To signify that it's not equal to, we use a boundary mark. We just use a dashed line. But follow the same advice as before. Would I be coloring in the inside or the outside of the circle? So on this example, I hope you have guessed that you'd be coloring in the inside, trying to do it as good as I can, of the circle. So that would be the graph that they're looking for in this. So just based on that information right there, I want you to see, based on that info, could you now draw this picture? And I bet the answer to that is yes, I could totally sketch that graph. Now, take a look here, because they have this guy. Well, that doesn't look like D. That doesn't look like question D here. And take a look at this guy. That doesn't quite look like question D either. And then this guy doesn't look like either of those. So what do we do about that? Well, I can't get everything done in one video, but I can kind of touch on this. What you're going to need to know is this guy right here. This guy is a hyperbola. And we'll get around to that. I'm going to do a separate video just for hyperbolas because they're a little bit more involved. This guy right here is an ellipse. Now, an ellipse is an oval. So it's one of those things where they taught you in geometry. All roses are flowers, but not all flowers are roses. All squares are rectangles, but not all rectangles are squares. So all circles are ellipses, but not all ellipses are circles type thing. So this guy right here, we're going to actually talk about graphing this one right now. We're going to get this done in this little video, and then we'll pick up the hyperbola later. And then, well, what about this thing and what about this thing? We're going to do that in a separate video. And then you should be able to tackle all the questions that you see in this AP Calc Summer packet. There's maybe one or two little things that I've already mentioned that I did not cover, but that's because they came from Algebra 1, and you should remember them. Or they're super easy to Google and get a really good explanation, and you could do it much faster than me making a video for you. So anyway, let's talk about the ellipse. Let's get this guy. Let's talk about him. So an ellipse, well, it has this look to it, just like they showed you there. An ellipse has an x squared component. It also has a y squared component, but it's supposed to be written equals 1. But let's suppose, what if it was equal to 25? What if they wrote equals 25? Well, you would say to me, hey, didn't we just sketch something like that? Isn't that just a circle with a radius of 5 and a center at the origin? Isn't that what it is? Yes, it is. But it doesn't look like, come on, it doesn't look like this. Well, let's get it to look like that. Let's get it there. So how would I do that? I could divide everything by 25. And if I divided everything by 25, that implies that I'm going to have something that looks like this. X squared over 25 plus y squared over 25 equals 1. Now, here's the deal with ellipses. This number underneath x represents the x motion I'm going to take. This number underneath y represents the y motion I'm going to take. So if I took the square root of 25, I would get plus or minus 5. That's x motion. So 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 to the left. And then, once again here, if I took the square root of that, I'd get plus or minus 5. But that represents my y motion now. So that means go up 5, and then go down 5, and connect all these dots. Once again, I apologize for my artistic ability. It's not great. Oh my God, that was really bad. Let me try that again. Oh my gosh, that was so bad. Okay. Okay, that's supposed to be a perfect circle. But see, like I said, all circles are ellipses, but not all ellipses are perfect circles. But if you want to sketch a circle and pretend that it's an ellipse, that's how you do it. And you might say, that's how I do what? Well, let's look at an ellipse. Let's look at something that is definitely not circular. So I'm going to do a real basic one, and then we'll mess it up a little bit. This guy is an ellipse. So I'm going to draw this one out, because one of the problems on your AP Calc Summer packet says, sketch the graph, right? Well, here's what I'm going to do. I'm going to take the square root of the number underneath x. And if I take the square root, I get a plus or minus 2. My x motion is plus or minus 2. So I get a guy here, I get a guy here. There's my center. Take the square root of the 9. If I take the square root of the 9, I get plus or minus 3. Hey, just like I did with the circle, I'm going to connect all these guys, and this would be definitely not a perfect circle, not just because I'm a really crappy artist, but because the distance that I travel on the y-axis is different than the distance I traveled on the x. So the thing is, I take the square root of the number under x, that gives me x motion. So I go 2 to the right, 2 to the left. I take the square root of the number 9, I get 3, positive and negative. So I go up 3 and down 3. I connect those dots. I have just drawn a picture of this ellipse. Let's play one more time, because I'm trying to get you guys to get 2 of these graphs accomplished on the AP Calc Summer Packet. But the one that they have, well, you know what? I'm just going to make one up that looks similar to it, and you'll see what I'm talking about. I'm going to put a 25 under here, and then I'm going to say something like this. Y, how about plus 3 squared? And I'll put the number 16 under here, and I'll say equals 1. This is an ellipse. If these two numbers were the same, it would be a circle. But they're not the same, so this guy's going to be an ellipse. Okay, now before I graph this, let's take a look. What is the problem they want you to be able to draw? Let me scroll back up. The problem they want you to draw is this guy. Well, look I made something that looks very similar. Here we go. Let's try and draw this, and then you go back and you try to do the one that's on the calc packet. So this would tell me my center is going to be not at the origin anymore. It's kind of just like a circle. The center for this ellipse is going to be at positive 2, negative 3. That's where the center of this ellipse is. So here we go. I'm going to draw my coordinates. Come on, help me out. Coordinate system. And I'm going to go right 2, down 3. There's my center. Now, I am going to have some x motion. The number under x, that's my x motion, but I take the square root of that. Oh my gosh, square root of that. And I get plus or minus 5. That's my x motion. So you have probably already figured out that if I took the square root of this, I'd get plus or minus 4. That's going to be my y motion. But where do I count? I don't go back to the origin. No, no, no. I'm going to go 1, 2, 3, 4, 5 units to the right. 1, 2, 3, 4, 5 units to the left. That's my x motion. Then I'm going to go 1, 2, 3, 4 units up. 1, 2, 3, 4 units down. And then I'm going to try to draw this to the best of my ability so it looks like an oval shape. But we don't call it an oval. We call it an ellipse. Okay? So we killed 2 of these graphs off with this lesson. We did. This Intro to Conics. I called this thing Intro to Conics Video 5. And we talked about the ellipse and the circle. Okay? The circle, the regular version of the formula is x squared plus y squared equals r squared. That's to give us a radius. Then I showed you how there's a fancier version of that formula. I wrote it right here. This is the formula for a circle that has its center being shifted either up, down, right, or left, or a combination. Then we did a couple problems like that. I also wanted to mention what it looks like when we put an inequality in the mix. And then we did a couple ellipses. Now, ellipses are when you cannot get the 2 bottom numbers to be identical. 2 bottom numbers identical, that's a circle. Bottom numbers different, that's an oval shape. And you can see that this oval right here is taller than it is wide, and this oval is on its side. And that is a fresh rhyme word. So, you got 2 of those accomplished. What did we not accomplish, though? We don't know what... Hang on, sorry. We don't know what to do here. We don't know what to do here. And do you see this one where it says find the center and radius of this circle? And guess what? That doesn't look like this. X minus something, I don't know, plus y minus something, I don't know, equals r squared, I don't know. That doesn't look like that. So how do we deal with this guy? Well, that's going to be the next set of videos. We still have to accomplish how do we get this done, how do we get this done, how do we get this done. And then you might see question 11 here, because it's grouped in the same spot in the packet. It says, state the symmetry, if any, for the graph of, and then they give me this picture they want me to look at. That has to do with something called odd and even functions. And that is one of those things I told you should look up, because there's plenty of really good stuff, and it's a visual concept you'll see. So please Google that one. Okay, so that's the end of this instructional video. On the next one, I'm going to pick up where I left off. Okay, guys, good luck.